Right. So now that we've graphed and we've learned how to evaluate all of these functions, now we're going to talk about what an inverse trig function is and what it looks like. So first of all, remember what you learned in Algebra 2, that a function, first of all, can only have an inverse if it passes the horizontal line test. Meaning, if you have a function and you draw horizontal lines through it, if each horizontal line only crosses the function at one point, then it can have an inverse function, meaning its inverse could also be a function. All right, as you can see, sine does not pass the horizontal line test, because if I were to draw a horizontal line through a sine graph, it crosses the graph an infinite number of times. So what does that mean? Does that mean we are never allowed to deal with inverse sine functions? Not at all, because inverse sine functions are actually a fundamental part of trig. So how do we get around this problem? Well, what we do is we restrict the domain of the sine function so that instead of saying the domain is negative to positive infinity, we only take this part of it from negative pi over 2 to pi over 2. And now if you only look at that blue curve, does that pass the horizontal line test? It does. So what we do is we restrict the domain of the sine function, and then we can define an inverse function, but only in that region. All right, so the domain that we're taking is from negative pi over 2 to pi over 2. This way, what we end up with is a restricted function. It's 1 to 1, meaning it passes the horizontal line test, and the range is still negative 1 to 1. Okay? Okay, so we literally throw away everything else in the sign. So for example, we're good if theta is negative pi over 2. We're good if theta is negative pi over 4. 0, pi over 4, pi over 2. But 3 pi over 4, we don't want it. 7 pi over 6, we don't want it. Negative 5 pi over 3, we can't use it. All right? We only are allowed to work with values from negative pi over 2 to pi over 2. That is the most important part of this. Okay? All right. So then we can get the inverse sine function. The symbol for it is inverse sine, like this, sine to the negative 1. Or arc sine of x. Those two are synonymous. You can either say arc sine or you can say sine inverse. They're the same. And that is the inverse of the restricted sine function. Okay, so the way it's read is y equals the inverse sine at x. And that's what it looks like. Okay, so let's take a look at some important characteristics between a function and its inverse. So if we look at f of x, the sign, for the restricted function, the domain is negative pi over 2 to pi over 2, and the range is negative 1 to 1, right? Now, in algebra, when you had to find an inverse function for something, how did you do that? What was the first thing you did to find an inverse? Huh? You would interchange the x and y. That's what inverse does, is it interchanges x and y. So now, if domain is all of the possible x values for a function, and range is all of the possible y values for a function, if I were to find the inverse function, then the domain will become the range, and the range will become the domain. All right? So with that, the way you graph, an inverse from its graph is you take a coordinate point, like for example here. Check out this coordinate point right there. Right here. X is pi over 2, y is 1. Here it switches. X is 1, y is pi over 2. Right? So this is pi over 2, comma 1. Here that same point is 1 comma pi over 2. So all of the x's become y's and all of the y's become x's. And when you draw the inverse, this is what it looks like. You see that the range is from negative pi over 2 to pi over 2. The domain is from negative 1 to 1. Yeah?
What if the period of a sine function is less than pi, is less than 2 pi? Or
still, we only take, yeah.
Does it hit pi over 2?
Right. Then we modify it there too. Okay. So we'll get into all of that.
If the period goes from negative pi over 4 to pi over 4,
right. Then you take only a quarter of that. So the inside quarter. Okay. What the inverse sine function does is it gives us the angle which has a given sine value. For example, we all know now that sine of pi over 3 is the big angle. The sine of it is root 3 over 2. We all know this. So then if I ask you sine inverse of root 3 over 2, now in that blue square, I'm asking you, what is the angle for which the sine is root 3 over 2? And you say, oh, root 3 over 2, that's the bigger side. The opposite angle must be pi over 3. Right? So it's pi over 3. So it's the question asked in the opposite direction. All right. Let's do a couple of examples, and then I'll take your question. Is that okay? Let's do a couple of examples. So here we're talking about inverse sine at root 2 over 2. So let's think about this for a minute. Back to this example, we have inverse sine of root 3 over 2 is equal to pi over 3. Okay? If the inverse sine is the function, right? If f is the function, then if you have, for example, f of x, the stuff in those parentheses here, that's the independent variable. That's your domain, right? So if you have f of x, x represents your domain. So that represents your domain. And in this case, it's from negative 1 to 1, right? Meaning, in order for this to work, the number inside those parentheses here is only allowed to have values between negative 1 and 1. So for example, I can't ask you what is the inverse sine of 2 root 3, because that's greater than 1. I can't ask you what is the inverse sine of 2, because that's greater than 1. All right? Right. It would be not defined.
All values all unit circle?
Huh?
All values all unit
No, just from negative pi over 2 to pi over 2. Okay? So let's do a couple of examples, and I'm going to tell you. Okay. And then the range here, and then this is the range. That represents the range. So in this case, it's going to be from negative pi over 2 to pi over 2. So that value, the answer, quote unquote, if you want to call it, it can only have values from negative pi over 2 to pi over 2. What does that look like? Where is negative pi over 2? Here. Where is pi over 2? Here. The values for the answer here can only be one of those values. So what are the values on this? This is 0, so you could have an answer of 0. This is pi over 3. This is, pi over 4. Pi over 6. This is pi over 3. This is pi over 6. And then here we have negative pi over 6. Negative pi over 4. Negative pi over 3. Right? How many is that? 1, 2, 3, 4. That's, how many values is that? 7. Your answers for these are only allowed to be one of those 7 numbers. Okay, so let's go to A here. We're asking, what is the inverse sine of root 2 over 2? What is the angle for which the sine is root 2 over 2? Pi over 4. What is the angle for which the sine is negative 2 pi? Huh? It does not exist. It does not work. Why? The pi is in there to confuse you. This is asking you what is the inverse sine of like negative 6.28. We said this could only be from negative 1 to 1, right? So this is not possible. Either. We just say no solution. Okay. Okay. So for the cosine, right? The restricted cosine function. Now cosine is a little bit different. So this is what it looks like. All right. And it doesn't go from negative pi over 2 to pi over 2. It goes from 0 to pi, right? So basically we look and we just want to take an arm of this that passes the horizontal line test. So, okay, we could have taken like negative pi to 0, but why? We always want like more positives than negatives. It was just an arbitrary choice. Some mathematicians got together and decided that's how it was going to be defined, okay? The inverse looks like this. So if it's from 0 to pi, that means all of the values that are defined for this are in these two quadrants, from 0 to pi. All right, that means your answers, your range, can only be 0, pi over 3, 3 pi over 4, right up to pi, okay? All right, so find the exact value, meaning no calculator, inverse cosine of 1, right? So I think of it as cosine is the x-axis, right? Cosine is x. Where is cosine 1? At 0. All right, arc cosine of negative root 3 over 2. So for which angle is it root 3 over 2? That's the big side, faces the big angle. But if I want root 3 over 2 to be here, then it's pi over 6. Now, pi over 6, but we want cosine to be negative, right? In the two quadrants where cosine is defined, it's negative in quadrant 2. So the corresponding angle there is 5 pi over 6. What if somebody said 7 pi over 6? 7 pi over 6 is right here. Right? Right here. That's outside its domain. It doesn't work. Okay? There's only one possible answer for these. Okay, let's do inverse cosine of negative 2.
Wait, so it's 5 pi over 6 because you want the large angle to be like on the x-axis?
Right. If this is root 3 over 2, the horizontal is root 3 over 2, that means the vertical is 1/2, so it must face the smaller angle, pi over 6. Okay, this one, not possible. Okay? So I always go pretty slow with the sign, and then cosine tangent, we just build on that. Okay? Yeah. Arc cosine and inverse cosine are synonyms. Okay. Inverse tangent. Again, we want one of these arms. So the best one to take closest to the origin is that one. And again, it goes from negative pi over 2 to pi over 2. But now, look at this. Look at the range from negative pi over 2 to pi over 2. Can it have a value of negative pi over 2 or pi over 2? No, there is an asymptote there. So that means at first glance, where it's defined might look the same as the sine. Okay? But whereas the sine, it includes all of these values, the tangent does not include pi over 2 and negative pi over 2. So it only includes the ones inside. Okay? All right. So inverse tangent at 1, for what angle is tangent 1? Pi over 4. Pi over 4, right? Tangent compares the legs and they're equal for 45-degree angles. For which angle is tangent root 3 over 3? Now, okay, so what do you guys think? Either pi over 6 or pi over 3. Okay, so look, there are always two possibilities for tangent, right? For the 30s and the 60s. Either root 3 or root 3 over 3. Which of those is bigger? Root 3 is bigger. It goes with the bigger angle. Root 3 over 3 is smaller. It goes with the smaller angle. All right? I know I said this before, but then it was when we were all fuzzy. This time maybe it'll make a little bit more sense. So it's pi over 6. So what if you were asked for arctan of negative root 3 over 3? Not D and E. Okay, so 5 pi over 6 is here, which is outside its domain. Where is it defined? It's defined from negative pi over 2 to pi over 2. So it would be negative pi over 6. Right? Negative pi over 6 here. Okay? I know it takes a little getting used to. Because we go with the graph. We go with the actual graph, and the graph is 1-to-1. It passes the horizontal line test for this one period, negative pi over 2 to pi over 2. Right? If you look on the x and y axis, it's negative pi over 2 to pi over 2. So on the unit circle, it has to be the same. Negative pi over 2 to pi over 2. All right? Yeah.
I'm just confused for how inverse tan would be pi over 4.
Well, we're asking for the angle for which tangent is 1.
Yeah.
Right? So what's tangent of pi over 3? Root 3 over, or it's root 3. What's tangent of pi over 4? So for pi over 4, that's like a 45-degree angle, right?
Yeah.
At pi over 4, if you draw the triangle, it's 1 over root 2, 1 over root 2.
Yeah.
The tangent is 1, opposite over adjacent. Yeah? Okay. So this is a summary of everything that we just said, and it summarizes the domain and range of inverse sine, inverse cosine, and inverse tangent. So notice the domain for inverse tangent is negative to positive infinity. That means it's okay if you have inverse tangent of like 300, right? You could have any number in there. The domain is all reals. But the range, right, is open parentheses negative to positive pi over 2. All right? Yes? Yes. Okay. So, yes, Gabby. Yeah. 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 Even if you go to like France, even if you go to the southern hemisphere, they're always the same. Okay? All right, so here's what I'm going to do. I'm going to leave the graphs till later. And so if you go to the next page, I like this chart more than the one up there. This is from another book. It's not from your textbook. Because it says the domain and the range here, and it also gives you the quadrants, right? So here we're looking at these two quadrants. Here we're looking at these two quadrants, and here we're looking at those two quadrants again. Okay? All right. So let me do some of these. Let me do some of these. Find the exact value of each expression if it exists. Okay, here we have sine of arc sine of 1/2. And it's like the inverse of the sine. So basically, it's just 1/2. You just have to make sure that this is defined. Right? So if it was like sine of arc sine of 3, it wouldn't work because you have to have a number in here that's less than 1. Between -1 and 1. Okay. Here, we could simplify these. So what's inverse tangent of 1? For what angle is tangent 1? Pi over 4 minus what's inverse sine of 1? Where is sine 1? Pi over, sine is the y-axis, so it's 1 at pi over 2. So here I have sine of that. This is sine of negative pi over 4. Right? And then what's sine of pi over 4 period? Root 2 over 2 or 1 over root 2. But if it's negative pi over 4, then it's negative 1 over root 2. Okay? Yeah. Well, I have a quarter pi in the red minus half a pi. A quarter minus a half is negative a quarter. Yeah.
So it'd be okay if we put root 2 over 2?
Yeah. As long as, yeah, negative. Okay. This one is a combination. So first we have to draw a triangle. We have to draw a triangle of the inside stuff. Okay. What is the inside stuff saying? I have a mystery angle, the cosine of which is 4 over 5. So, here's an angle.
Isn't the cosine inverse of it?
Okay, so what that says is, if I was walking down the street and saw that on a billboard, just inverse cosine of 4 over 5. To my mind, it registers, find the theta for which the cosine is 4 over 5. Okay? This means the angle for which cosine is 4 over 5. We translate it as, I have an angle, the cosine is 4 over 5. So now, can we find the missing side? It's 3, right? Either Pythagorean or we figure that out. And now, what are we looking for? We're looking for the sine of this angle theta. So that mess represented theta. And if I want the sine of it, then it's 3 over 5. All right? So we draw the triangle first, then that. Okay, so that's kind of cool, but with numbers, it's not that exciting. What if we had a variable? So same thing. Notice how these are pretty much the same. You have a trig function outside, an inverse trig function inside, and then it's just the values that are different. So here we're going to draw a triangle again. We're going to draw a triangle of the inside. This is telling me that there is an angle theta. The sine is x. That means opposite over hypotenuse is x. All right? So now I want to find that missing side, this missing side. All right? How would I find that? So let's say that's b, right, for ABC. X squared plus b squared is equal to 1 squared. So b squared is 1 squared minus x squared. B is the square root of 1 minus x squared. Well, here, I should have had a square there, right? Because it's a squared plus b squared equals c squared. Oh no. Okay, so this 1 minus x squared actually means 1 minus x, 1 plus x. So you can't take the square root, right? Okay, so now this side is 1 minus x squared. Okay? And then we're going to do another one right now. So the cosine is what we want, is the square root of 1 minus x squared over 1, which is just root 1 minus x squared. Well, that's what I just said. 1 minus x squared, that's really 1 minus x, 1 plus x. So you can't take a square root. So think about that. If you have the square root of 4 minus 9, that's, well, 9 minus 4. That's the square root of 5. Is that right? You can't say that that's the same as like 3 minus 2. Right? That's not, you can't just take the square root of the 9 and then say that that's 3 minus 2. Okay, so that's the cosine there. All right, so let's do this one, the tangent. We have a triangle. The cosine is x over 1. Okay, now I need to find this side, right? Okay, so here's what I do. Here's what I, Miss Malikian, do. When I have a right triangle. This hypotenuse is always the largest one, right? It's always, one of the legs are always going to be the square root of the larger one squared minus the smaller one squared. If you don't believe me, do the Pythagorean theorem, but I promise it'll be the same. And so that's my little shortcut to doing them. If the hypotenuse was 9 and this leg was 2x, right? If the hypotenuse was 9 and this was 2x, what would that side be? It would be 81 minus 4x squared, right? Always. So, but now, if this was 9 and this was 2x, now for the hypotenuse they add. So it would be 4x squared plus 9. Okay? So you could always, 81. You could always just do the Pythagorean theorem. Like you could always just do the Pythagorean theorem. These are little shortcuts and I just offer them. Especially in this class, I always offer these things. If you want to use them, all the more power to you. If you don't want to use them, that's fine as well. Okay? But I want you guys to be able to, you know, like do some things mentally and then, you know, spend time on the bigger ideas. Okay? All right. So here, speaking of a bigger idea, what is the tangent of this theta? Yeah, what you said. Okay? All right? Yeah. Yeah. So first I had this, and it says the inverse cosine of x. It means there is an angle theta here, and the cosine is x. It means the adjacent over the hypotenuse is x over 1. Okay? And then I want to find this side. And for that one, I could either do the Pythagorean theorem, or I could do a little shortcut where I know that it's the square root of the larger side squared minus the smaller side squared. And then tangent is opposite over adjacent. Okay. So, suppose you went to the movies and there was a 32-foot tall screen, right? and it's located 8 feet above the ground. So you know, like if you go to the movies, like the screen, it starts up here and then it goes up, right? So there's like a whole bunch of empty space on the bottom. So that's what this is talking about here. There is an 8-foot gap, and then there's a 32-foot screen. Write a function modeling the viewing angle theta for a person in the theater whose eye level when sitting is 4 feet above the ground. Okay? Okay. So here is this person. They're 4 feet above the ground. Okay? And that's their eye level. The viewing angle is theta. The viewing angle is this, basically. It's the shaded part. Do you guys see it shaded over there? Yeah. No, that's not theta 2. Listen, let me do this. This is theta. Theta is the viewing angle. Basically, it's from the bottom of the screen to the top of the screen. Theta, okay, so what are theta 1 and theta 2? Theta 1 is this tiny little sliver between the bottom of the screen and your eye level, okay? Theta 2 is from the top all the way down to your eye level. So theta 2 is the entire angle. Basically, theta 2 is theta plus theta 1. Okay? We want a function for the viewing angle theta. What we want is theta, which is theta 2 minus theta 1. Okay? All right. Well, how are we going to do this? Well, if we just focus on theta 2, right? If we just focus on theta 2, that's this one here. Let me do it in red. That's theta 2, that triangle, right? Can we talk about the tangent of theta 2? That's 32 over, I'm sorry, no, that's not 32. How much is it? It's 36 over D, right? Because, so, 32, okay, so this part here is 8. You're sitting at 4 feet, so this is 4 and that is 4. Okay? So that's 36 over D. Now, tangent of theta 1, that's that tiny little sliver there. That is 4 over D. Okay? Now, theta is theta 2 minus theta 1. So we need to solve all of these for theta. All right, well, let's solve the first one for theta 2. If tangent is this, then theta 2 is inverse tangent of 36 over D. So then what would theta 1 be? Correct. Inverse tangent of 4 over D. So then theta, if it's theta 2 minus theta 1, theta would be inverse tangent 36 over D minus inverse tangent of 4 over D. And if we wanted to write a function and the variable is D, then instead of theta, we could do theta of D. And that is it. That is the viewing angle. So you can take that with you, and based on the parameters of any theater, you could figure out what the optimal viewing angle is for you. All right? So now it says, determine the distance that corresponds to the maximum viewing angle. All right? So we want the viewing angle theta to be a maximum. So theta D to be a maximum. Okay. We're going to graph this. This is real life. We're measuring an angle. We're measuring a distance. They're both positive. Normally, we would have an x and a y axis. But what's our independent variable now? D. And this is theta of D. Okay? So if we graph this, if we clear that, and if we graph inverse tangent, of what is it? 36 over D over X minus inverse tangent. All right. You guys are graphing this with me, right? So menu 4 and 8. And obviously we're not going to see anything. What's your maximum theta? So what's your values of theta going to be? It's going to go from 0 to 90, right? So we go here, menu 6. Not 6. Yeah. Okay. Where are you? 4, 1, 0 to pi over 2. I thought you guys were graphing with me. What do you think the distance, how do you think the distance is going to range?
From 0 to 1.
0 to 1? That's how far away the maximum distance? How many feet do you think? Infinite? Is that how big? How big is that movie theater? Distance is how far back you're sitting. So what's a reasonable range for how far back you could be sitting? Okay, 50 or 100. I started typing 100 first. And why can't I see a graph? I'm gonna find out next time. All right, I'll continue that graph next time. Next class is our last class together. So I'm just gonna go over that little bit of a graph. It takes 5 minutes. And then I'm gonna give you guys the practice test to work on. I want you to do this homework for next time, but skip the graphs. Skip the ones where it says to graph the inverse sign. Do all the rest for next time, okay? All right, I'll see you guys next week.